Class, welcome to lesson 1.7, horizontal stretch, compression, and reflection. So today's lesson is brought to you by the letter K. Let's just review some warm-ups and what letters we do know from the previous lesson, the A, D, and C. So as we learned yesterday, we learned about transformations of parent functions and what each letter does. Now, just to let you know is that we're going to be reviewing the A, C, and D that we covered in last day's lesson, but today we're adding in the last letter that completes all of the possible transformations, and that's the letter K. But first of all, this is an example of the answers you should have from last night's homework from the handout. So please make sure that you check these over, and if you need any help, please come and see me. Let's just go over one into detail. So let's, for example, take a look at C. I'm just going to grab my highlighter here. Okay, so taking a look at example C, we should recognize that it's an absolute value function. So the parent function is the absolute value of x. And then we notice that the numbers in front are 1 over 4. That's your A. A equals 1/4. Again, think of that as being a compression from the top and the bottom in the vertical direction by a factor of 1/4. That means that you are going to push it down to almost flatten it like a pancake. Next, we should spot that D, normally it's x minus D, but we've got x plus 3. So that means D must be negative, and it's a value of 3. That tells you it's a horizontal translation, left 3. And in the last example, the number at the end, that is your C, and C equals -5. That means it's a vertical translation, down 5. Okay, I apologize. I have no idea what's happening to my computer. I'm just going to pause it for a second. Okay, sorry for those technical difficulties. My computer seems to be working better now. We just went over example C, but again, A, B, C, and D are there to take a look at and double check from last night's homework. As I mentioned, ladies and gentlemen, today we're going to look at K. I would like to just flip to the fourth page for a second. We'll come back to this stuff in a minute. If you have an elastic, please go at home and find a regular elastic and pause this until you get the elastic, and then let's go over it. Okay, looking in the center here, ladies and gentlemen, as I grab my highlighter, we notice that, look at this, ladies and gentlemen, here is the elastic just without any stretch or compression. So normally as it sits. When we look at A, ladies and gentlemen, remember there's a force from the top or the bottom. So when we take a look at a vertical stretch, that elastic becomes narrower. Okay? Likewise, if we do what's called a vertical compression, we're pushing down on the elastic and it flattens it out. Okay? So that depends on the value of A. If the absolute value of A is greater than 1, it's going to be a vertical stretch. And if we go the opposite direction, if the absolute value of A is less than 1, then it's a compression. So it makes it like a pancake. And then we also know that A is negative. It reflects the x-axis. Now to introduce K, ladies and gentlemen, K is a little bit different, especially in that the factor is over the 1 over the absolute value of K. So it's a little different when we take a look at this. The difference is, ladies and gentlemen, now we're taking a look at the horizontal way of doing this, okay? So now take your elastic and pull it from the left to right side. When you pull it away, it stretches it and makes it look flat like a pancake, but that's the horizontal stretch, not a vertical compression. Okay, so again it becomes flat, and that happens, ladies and gentlemen, when K is between 0 and 1, and I'll explain that in our lesson, and we'll review this at the end. The other thing that you could do is take your elastic and push them together from the left and right side, and you're going to get what's called a horizontal compression. In doing so, ladies and gentlemen, you make it look narrower even though you're pushing it. But just remember, it's from the horizontal push that's causing this. So an example of that would be in your equation, K would look like 4. And remember, you would make it 1 over the absolute value of K, which means it'd be by the factor of 1/4. This time, ladies and gentlemen, K is negative. It doesn't reflect the x-axis, but it reflects the y-axis. So we've got shifting in both directions now in terms of reflect. So make sure you're very specific from now on when you reflect the x-axis and when you reflect the y-axis. So again, today we're going to be talking a lot more about K. We're going to go to the beginning of the lesson, and hopefully that was a little introduction for you. Okay, here we go. Lesson 1.7, horizontal stretch and compression. Again, ladies and gentlemen, if you have a graphing calculator, or you can go to my website and do some graphing, this will help you visualize what's actually happening. So if we start off with our parent function, which is y equals x squared, we're most familiar with the quadratic, so that's why we're going to start by taking a look at that. Ooh, bad highlighting, sorry. Okay, looking at that, ladies and gentlemen, it's in the black as the graph. We know our step pattern. As you go over 1, you go up 1. As you go over 1, you go up 3. As you go over 1, up 5. So that's your standard parent function for y equals x squared. Now for the second one, notice, ladies and gentlemen, that we have 2x all raised to the power of 2. So in this case, guys, k equals 2. What has happened is instead of the point being here, notice that it's half as much in, or if we take a look here at our key point where x was, let's go over here on the positive side, guys, where x is 1, it's now been and y is 1, it's now x is 1/2. So what's basically happened, folks, is it's gone half as much, so that's why we call it a horizontal compression. And whenever you have a k factor, you put it 1 over the absolute value of k, so that's why it's going to be by a factor of 1/2. Again, I'll explain that formula later. Just wanted to introduce it so you're used to that terminology. Next, let's take a look at the green equation, or y equals 1/2 x, all raised to the power of 2. In this case, ladies and gentlemen, if we take a look from our magic point here, it was at 1, and now it's at 2. So horizontally, we have stretched it out further. So it's twice as wide as that used to be. Just imagine taking that elastic, ladies and gentlemen, and pushing it twice as wide from the left and the right, as opposed to the top and the bottom. Okay? So basically what's happening, ladies and gentlemen, is we have the k, and the k always appears directly in front of the x. Remember, a would be outside of the brackets here. K is inside the brackets. Okay? So if k equals 1/2, actually it's going to be stretched. If you could put it in the formula 1 over k, it's going to be stretched by a factor of 2. As you can see in the diagram, between the parent function where x is 1, it becomes x equals 2. Okay? Because it's been stretched twice as much. So let's go over and make a rule about this, okay? So taking a look here, ladies and gentlemen, we want you to write this out or make sure you've got this in your notes, okay? The formula we're developing here is k. And in order to take a look at k, you look at it from your translation menu, okay? So k is going to always be directly in front of x, okay? Or directly attached from x. So take a look here, guys, right here. Okay, so it's always going to be inside the brackets, just like the numerical coefficient of x, basically, ladies and gentlemen. But what we need to do is remember, when we're representing the horizontal translations, okay, it becomes 1 over the absolute value of k. Remember, it also can reflect the x-axis if it is negative. Okay, so let's take a look at some examples here. Example A. Okay? If in example A, we're looking for a horizontal compression, okay, then we know that k, absolute value of k, has to be greater than or equal to, or sorry, greater than 1. So your example would be k equals -7. Again, the negative part just tells you that you're going to reflect the y-axis, but the 7 part is what we're concerned about. So again, you put it in 1 over absolute value of k, sub it in like this formula right here, guys, okay, that I'm highlighting a little bit more. Sub it in, and remember, absolute value of any negative value just becomes positive. So therefore, guys, we have a horizontal compression by a factor of 1 over 7. The important is to realize that in your equation, k will look at -7, but when you talk about the factor, it's always 1 over the absolute value of k. Second example here is when you're taking a look at a horizontal stretch, okay? That occurs when k is between 0 and 1, i.e. a fraction. And just remember, guys, when you put a fraction into a fraction, you invert and multiply. So in this case, k is originally 1 over 2, but to talk about the factor of it, of how much it's been stretched by, it's 1 over the absolute value of k. Again, you're dividing a fraction by a fraction, so you invert and multiply. So in this case, the factor would be 2. So you would say a horizontal stretch by a factor of 2. Okay? And the last part to remember, folks, if k is less than 0, i.e. it is negative, then it's going to reflect the y-axis. All right? The other part I want you to write down is sometimes in your equations, the k part is not factored out, so you need to factor it out. So always factor out k when possible. I have many people on their unit test that tend to miss that, so please make sure you remember to do that. Here's an example where you need to factor out k. Looking at this function here, ladies and gentlemen, please note it's a square root function, okay? And it says 5 minus x. But remember, when we write it in proper form, x has to come first. But it's not just x. There's a -1 attached to x, so you common factor out a -1 here, guys. And what's left over, I just changed the order, is x minus 5. So what we're talking about here is the fact that k equals -1. Okay? Let's move on and take a look at some other graphs. And again, if you have a graphing calculator, you may want to plug them out and try these. So on a separate set of axes, graph these. I'm actually going to put them all on the same set so you can see, in fact, what's happening, especially to some of the key points. Just remember, ladies and gentlemen, when you have your parent function, in this case we've got a square root function, you want to enter values in for x that will evenly go into the square root. So that's why I'm choosing points 0, 1, 4, and 9, because they all are perfect squares, i.e. you can take the square root of them easily. I would not be choosing points like 2 and 3 and 5 because it's not easy to get the square root of that. So doing that, ladies and gentlemen, you have your parent function, which is here in the black. Okay? And remember, you've got that key point 1, 1. We're going to be focusing on those key points to help us here. Okay? Now, in the second example here, folks, it's no longer the square root of x, it's the square root of 2x. What does that mean? When I pick values here now, I've got to take my values that I originally had, and I've got to divide them by 2, so that when I sub them in, they will cancel. So 2 times 1/2 will actually end up being 1. And I'm going to take the square root of 1 to be 1. Okay? So after I've subbed in my found appropriate values from our independent and subbed them in, I now have some output values. So let's take a look what happened between the black graph and the blue graph. Okay? So before my key point was 1, 1, now it's 1/2 and 1. What does that mean? That means it's gotten half, half is the distance. Okay? So basically that's what we call a horizontal compression. Okay? We're pushing from the left and right in and it's bending outwards. Okay? All right? Taking a look at C, ladies and gentlemen, again, I choose appropriate values to sub in for x so that I will easily have some nice values for y. So I chose 2 because 2 divided by 2 gives you 1. And then you take a look at 8. 8 divided by 2 gives you 4. Then you take the square root of 4, which gives you 2. Okay, so again, you're picking nicer values or easy values for this, or just plug it in a graphing calculator, ladies and gentlemen, and you'll be able to see that as well. Okay, so looking at the green graph, which is y equals half x, you notice that that key point 1, 1 is no longer 1, 1. It's now 2, 1. So what's actually happened, folks, is if you imagine that elastic and you're pulling it left and right and you're trying to stretch it out horizontally, you'll notice that it's getting twice the distance out here. Okay, so what does that mean? Again, k equals 1/2, but when you put it in the factor 1 over the absolute value of k, you will note that it's a horizontal stretch by a factor of 2. How can you tell? Because your key point has made it twice as far in the horizontal direction. Okay, and my last example here is D. Okay, this is hard for people to understand. If you have the absolute value of a negative value of negative x, that is still possible, i.e. k equals -1. All you need to do is to remember to substitute in negative values so that a negative times a negative will become a positive. So obviously when k is negative, we say it reflects the y-axis. Okay? So it is basically a mirror. The red graph is basically a mirror image of the black graph around or by the y-axis. Okay. So again, the key point there. It used to be over here on our parent function 1, 1, but here it's -1, 1, which is just its mirror image. All right. Okay, let's do a summary of everything. We'll put everything together. So ladies and gentlemen, this is as hard as it gets in terms of your equations. Again, this equation here that tells you transformations for any function, I will provide that on your test, so you don't need to memorize it. But you do need to know what each of our transition letters do, i.e. what does A do, what does K do, what does D do, and what does C do. And it's summarized all right here, ladies and gentlemen. So I would make sure you star this in your textbook or in your notes and say study for test. Okay? Let's just quickly go over the things that A does. If A is less than 0, either it's negative, it's going to reflect the x-axis. If the absolute value of A is greater than 1, it's a vertical stretch by a factor of A. If A is less than 1, it's a vertical compression by a factor of absolute value of A. Now we're taking a look at the K. This is the newer stuff. If K is less than 0, i.e. if K is negative, it's going to reflect the y-axis. The absolute value of K is greater than 1, then it's going to be a horizontal compression. And don't forget to put it into the equation 1 over the absolute value of K. Here's an example here. If K equals 3, it's going to be a vertical compression by a factor of 1/3. Looking at the opposite for K, if K is less than 1, so between 0 and 1, we know that it's going to be a fraction, okay, and it's going to be a horizontal stretch. Again, don't forget to put K into the formula. It's easier to take a look at the second example first, and then I'll explain the first one after. So if K equals 1/4, you put it in its fraction and you flip it, and K would be, so it'd be a horizontal stretch by a factor of 4. That means from the key point, it's going to be 4 times the distance away than it was in the original parent function. Another one to make note to make sure that you guys can take care of or make sure you know how to do is this example 1. And I just lost my highlighter, so I apologize. Let me go get another one out here. Okay, so in this case, K is -2/3. Okay, the negative part tells you that it's going to reflect the y-axis, and the 2/3, you put it in the fraction, it's just going to flip the fraction. So it's going to be a horizontal stretch by a factor of 3/2. And 3/2 is just 1.5. So you will notice, folks, that it's stretched horizontally. That key point will be 1.5 times as far away as the parent function is. That's the hard part. That's the new one for today. Okay, now we'll take a look at D and C. Hopefully you remember those from grade 10, maybe just in terms of P and Q though. If D is less than 0, it's a horizontal translation to the left. If D is greater than 0, it's a horizontal translation to the right. And C is your vertical translation. If C is if C is less than 0, it's going to go that many units down. And if C is greater than 0, it's going to go that many units up. Again, that is a good thing to study for your study sheet. Here is our homework. However, I will, ladies and gentlemen, just go back over and review the difference between the K and the A, just to make sure you've got a better understanding now that we've gone through it in the class. So let's just quickly review this, ladies and gentlemen. When you're dealing with A, that deals with your stretch. or compression in the vertical sense. So again, practice that elastic, pulling it from the top and the bottom or pushing it from the top and the bottom. Whereas K, ladies and gentlemen, take your elastic and go from the left and right side and stretch it or compress it. Please also note, ladies and gentlemen, that you could have an equation that has both a compression and a stretch from A and or K. So these are in combinations, and we will learn through a mapping lesson how to deal with that case where you've got both options happening. Okay? So again, let's just take a look at some examples here at the bottom that we didn't deal with. Okay? So take a look at this example right here. I'll highlight it quickly. Okay? So if we have this expression, ladies and gentlemen, and this is a quadratic one, okay? So what can we tell? We can take a look here and we can say that, hey, A is what value? A is 1/2. What does that tell us? That it's a vertical compression by a factor of 1/2. K, in this case, is -3. The negative part tells you that it reflects the y-axis, and the 3 part you put into the absolute value, 1/K, right? And it's going to be a horizontal compression by a factor of 1/3. And the other two, D equals 2, that tells you that you've got horizontal translation to the right, and C equals 4, which is a vertical translation up 4. Again, that's as hard as it gets, ladies and gentlemen, and I can just see that here we're missing a plus C, so I will try my best to write it in. Just probably got erased off. See if I can put this in. So plus C. Okay. So again, folks, I'll now go back to our homework. Please give a try with this, ladies and gentlemen, and the better you can practice with some graphing calculators, the better it's going to be. So your homework right now today is page 58, numbers 1, 2, and 11, and page 70, number 4. That's a starred one, so it might be tricky. Just remember, folks, to factor out K when need be, and to understand the different forces between A and K. Again, please come and see me with any help, and have a great day.